Hi everyone. In this lesson, we are beginning section 3.3, where we'll learn two of the most important rules in probability. We'll start with the multiplication rule. As we have seen throughout our study of probability, many situations involve more than one event. Instead of finding the probability of a single outcome, we're often interested in finding the probability that multiple events occur together. For example, what is the probability of drawing a king and then drawing a queen? What is the probability of selecting three defective phones in a row? What is the probability of drawing two red marbles from a jar? Questions like these all have something in common. They require more than one event to occur. That's exactly where multiplication rule comes in. Before we start calculating probabilities, let's first talk about when this rule should be used. The multiplication rule is used when two or more events must both occur. When reading a probability problem, there are several keywords that should immediately catch your attention. Those multiplication keywords include and, both, then, followed by, and or. When you see these keywords, it's a signal that multiplication may be required. Now, I want to emphasize the word may. Don't automatically multiply just because you see one of these words. Instead, ask yourself one simple question. Do all of the events need to happen? If the answer is yes, then the multiplication rule is usually the appropriate tool. Let's think about a simple example. Suppose I ask for the probability of drawing a king and then drawing a queen. Drawing only the king isn't enough. Drawing only the queen isn't enough. Both events must occur. Because both events are required, we will use the multiplication. That's the big idea behind today's lesson. The multiplication rule helps us calculate the probability that multiple events occur together. Now that we have identified some common keywords, let's practice recognizing multiplication situations. One of the biggest challenges students face isn't actually doing the calculations. It's deciding which probability rule to use in the first place. So, before we worry about formulas, let's look at a few examples and ask a simple question. Should we multiply? Take a look at this table. The first situation is drawing two red marbles. Should we multiply? Yes. Because both marbles must be red, both events must occur. Next, consider drawing a king and then drawing a queen. Should we multiply? Yes. The key word here is then. We need both events to happen in a specific order. Now, let's look at this situation. Three defective phones. Should we multiply? Yes. We are interested in the probability that all three phones are defective. Every event must occur. And finally, consider the event heart or spade. Should we multiply? Nope. Notice the word or. We are not requiring both outcomes. Either outcome would satisfy the condition. This is not a multiplication problem. Before we continue, let's briefly connect today's lesson to what we learned in the previous section. Last time, we learned about independent and dependent events. I'm not going to spend much time reviewing those ideas because we have already covered them. But let's do a quick refresher. Independent events are events where one outcome does not affect another outcome. Dependent events are events where the first outcome changes the probability of the second outcome. The reason this matters is that the multiplication rule has slightly different formulas depending on where the events are independent or dependent. For independent events, P of A and B equals P of A times P of B. For dependent events, P of A and B equals P of A times P of B given A. Let's talk about this notation. This is read as the probability of B given A. In other words, it represents the probability that event B occurs after event A has already happened. The important idea is that the probability of the second event may change because the first event already occurred. That's why dependent events require a slightly different formula. Now, don't worry too much about the formulas right now. Our goal for this video is simply to recognize when multiplication should be used. We'll apply these formulas in the next video. There's one more idea from the previous section that we'll need throughout today's examples. That idea is replacement. In many probability problems involving selecting objects from a group, such as marbles, cards, cookies, and other items, after an object is selected, it can either be replaced or not replaced. This decision affects the probability calculations. If an item is selected and then returned before the next selection, we call that with replacement. Because the item is returned, the total item of objects stays the same. The probabilities do not change. Those events are independent. If the item is not returned, we call that without replacement. Now the total number of objects decreases after each selection. The probabilities change. Those events become dependent. And when the problem does not mention whether the selections are made with or without replacement, we will always assume without replacement.